Hey guys, it's Miss Adelini here with a sex linkage video tutorial. So let's go ahead and get started. Up until this point, we've been looking at genes that are found on autosomes, which are non-sex chromosomes. Today we're going to be looking at the inheritance of genes that are located on a sex chromosome, so either an X chromosome or a Y chromosome. Those are called sex-linked genes, and more specifically, genes found on the X chromosome are called X-linked genes, and genes found on the Y chromosome are called Y-linked genes. This was first discovered by a scientist named Thomas Morgan. He was the first person to identify genes located on sex chromosomes. He worked with fruit flies, a really popular study organism for geneticists. For a couple reasons. They're really small, so you can have a lot of them in a small space, and also they're easy to mate. They have quick generation times, so you can track the changes from parents to offspring and the inheritance of traits very easily. An example of a trait that he looked at that was sex-linked was eye color in fruit flies. There are two variations. You could have red eyes or white eyes. And what Morgan noticed was that there were a few white-eyed males, but very few, if any, white-eyed females. And he determined that because there was a difference between the sexes in terms of eye color, they must be sex-linked. The genes for eye color must be sex-linked. So he came up with the conclusion that the gene for fruit fly eye color is on the X chromosome. Now that might confuse you a little bit because you might think, hey, males have a Y chromosome and females don't. So isn't it more likely that a gene found in mostly males would be on the Y chromosome? Well, first of all, some females do have white eyes, so that rules out the Y chromosome. And the reason that traits on the X chromosome tend to be more common in males is because, let's go to a random Word document. Females have two X chromosomes. Make this real big. And males have an X and a Y chromosome. Now let's say a gene is recessive and it's found on the X chromosome. Let's say we're going to use little a, to represent that recessive allele. Now notice that since a female has two X chromosomes, she needs two copies of that recessive allele to show the recessive trait or the recessive phenotype. A male, since he only has one copy of the X chromosome, only needs to have one copy of that recessive gene in order to show the recessive trait. So that's why males typically show X-linked traits more often, because they only need to receive one copy of a recessive gene. Okay, so let's go back. Let's say we're talking about eye color in fruit flies. And our red eye allele is going to be the dominant allele, again carried on the X chromosome, so we'll put an X and then a big R superscript for our red eye. Then we're going to use for our white eye allele, again an X because it's on the X chromosome, but a little r since white eyes are recessive to red eyes. Okay, we're going to do a couple example crosses. Let's say we're starting with a red-eyed female who's purebred or homozygous for red eyes. So she's going to have two big R's on her X chromosome. We're going to cross her with a white-eyed male. So he is going to have an X with a little r, and as usual with males, a Y chromosome. So let's say I'm going to put my female gametes, each one carrying one copy of that X-linked gene, and my male gametes on the left side. When I fill in my Punnett square, I'm going to follow basically the same rules. I'm always going to put any big R's before little r's, and I'm also going to put X's always before Y's. So when I fill in my offspring, notice that I end up with 2 out of 4 being girls and 2 out of 4 being boys. That accounts for the near 50-50% sex ratio in the human population and in the fly population, since we are talking about flies. Wow, you can tell I'm real tired. Okay, for our phenotype ratio, we're going to end up with 50% of our babies, 2 out of 4, being female, and these 2 females here are going to have red eyes since they have at least 1 copy of the dominant red eye allele. My other 2 babies are boys, so we have 2 red-eyed males since they both have a copy of the big R. Let's try our second example. Let's say we were crossing a female who had red eyes but is considered a heterozygote because she has 1 big R and 1 little r. We're going to cross her with a male who's red-eyed. He has a big R. Put our female gametes on top, our male gametes on the left side, and we'll fill in our babies. Okay? In our phenotype ratios, we end up with 50% of our offspring, so these 2 babies being red-eyed females, 25% out of, or 1 out of 4 being red-eyed males, and 25%, or 1 out of 4 being white-eyed males. Okay. Now I want to talk about a human example of sex linkage. Hemophilia is a condition that causes the blood to clot incorrectly. It's an X-linked disorder. It's recessive, so we're going to use X big H to represent the normal allele and X little h to represent the recessive hemophilia allele. Now, people who have hemophilia will not necessarily bleed out, but they'll bleed a lot after a minor cut. Today, we have medications that can help people's blood clot even if they have hemophilia, but back in the day this could have been a fatal disease. If you've ever seen the Disney movie Anastasia, it's based on Anastasia Romanov, who was a member of the Russian royal family, and hemophilia ran in her family. Now, it was most common in the males since they only had to receive 1 copy of that recessive allele to show the trait. So I think her brother Alexei had hemophilia, although they didn't know at the time what it was. Okay, so let's say we're starting with a mother who's a carrier for hemophilia. What it means to be a carrier is that you are normal, you have a big H on your X chromosome, but on your other X chromosome you do carry the recessive allele. You don't show the trait, but you can pass it on to your offspring. So you're considered a carrier or a heterozygote. And that would be this individual right here, X big H, X little h. For the father, he's normal, so he's going to have just an X big H. So let's put the carrier mother up top, the normal father on the left-hand side, and fill in our offspring. And with our phenotype ratio, we end up with 50%, 2 out of 4 normal females, although 1 is a carrier, this one right here. We end up with 25%, or 1 out of 4 normal males, and then 25% males that are X little hy, and that male would have hemophilia. All right, and that's all I got for you. So hopefully this was helpful for learning about sex-linked genes, and I'll see you next time. Bye-bye.